Hi there, welcome to a continuation of Module 8 where we will be solving 2x1s, 3x1s, and 4x1 multiplication problems, not only using partial products like you saw in the last video, but now beginning to incorporate that area model into solving these types of problems. Because partial products and the area model are very similar, they're just set up differently. So we're going to look at this first problem here. We have 424 times 3. Well, before I do anything else, I'm going to go ahead and set my problem up like I would normally see it vertically. So 424 times 3. Okay. Now I'm going to solve this first with the area model because this is what we were really familiar with at the end of last week. So as I begin to think about how am I going to set up my area model, well, I'm thinking area is length times width. So as I decide where to put my numbers on my diagram over here on the right, I've got to think about how I am multiplying, or what two numbers I'm multiplying. That way I can place them on the right parts of my diagram. The other thing I need to think of is I want to be able to break up 424 so that it's easier for me to multiply. So I need to break it up based on its place value. And a lot of times we think of this when we did expanded form, we were breaking the numbers up based on their place value. So if I think about how many digits 424 has, I know it has 3 digits, which is an automatic tell for me that I'm going to have 3 sections to my area model because I need 1 section for each place value. The next thing I need to do is think about what do each of those digits represent in that place value. So for instance, 4 doesn't just equal 4, it is 400. The 2 doesn't just represent a 2, it represents 20. And the second 4, it does in fact just equal a 4 ones. So now I take those 3 numbers, and that's what's going to go on the top of my chart here. So I'm going to have 400, 20, and 4. And again, if I think down here, area equals length times width, I need to think about what am I going to multiply each of those numbers by? Well, I'm going to multiply them by 3. Alright, I've got my area model set up. Now it's time to solve. So I'm going to end up, this first box is going to be 400 times 3. My second box is going to be 20 times 3. And my third box is going to be 4 times 3. Now you don't have to necessarily write those equations in there, but if you think that that will help you to make sure that you're multiplying the right numbers together, I highly recommend it. What you do need to make sure you have are those numbers written on the outside of your rectangle though. Those are a must. Okay, so let's go through and solve those problems now. 400 times 3. Well, I know my math fact of 4 times 3 is 12. And I'm multiplying that by 100, which tells me I'm going to move those over 2 place values, and it'll give me 1,200. 3 times 20, well, 3 times 2 is 6, and I'm going to multiply that by 10, so I'm going to shift it over 1 and end up with a 1 0 on the end. And 4 times 3 again is 12. Okay, I've solved now for each of my sections of my area model. The last thing I've got to do is add them up. So I'm going to take 1,200 plus 60. Notice I'm lining those up really well so that they don't mess up my place values. And 12. And then I'm going to go ahead and add 2, 7, 2, and 1. So my answer right now, based on my area model, to 424 times 3 is 1,272. Alright, we're going to check this now by performing this problem using partial products. Again though, this is almost the exact same as this area model, it's just formatted a little bit differently. So in the respect of my vertical problem, I'm going to label each of my place values so I know exactly what number I'm multiplying by. So my 4, I really am multiplying by a 4. My 2, though, I'm not multiplying by 2, I'm multiplying by 20. And my 4 isn't just a 4, it's a 400. Alright, now I'm ready to multiply. So first things first, I say 3 times 4 is 12. Then I take my 3 and I multiply by the tens place. So 3 times not just a 2, but a 20. 3 times 20 is 60. And finally, my 3 times my 100 place, not just 3 times 4, but 3 times 400, is 1,200. And then again, just like the area model, once I've solved all of those, I add them up. So 2 plus 0 is 2. 1 plus 6 is 7. 2 plus those invisible zeros are 2. And then finally a 1. So notice, same answer checks out for both of them. And if you also notice here, my 3 numbers that I'm adding together are the exact same that I gathered from my area model. So it's just a matter of how you're solving this, how you're setting it up for you to best understand the outcome. Alright, we're going to practice another one. This time we're going to have a 4-digit by a 1-digit, but the process is the exact same. You've just got one additional digit that you've got to multiply by. So again, I'm going to rewrite my problem. I have 1,424 times 4. That'll get me set up really nicely for my partial products. But I am going to go ahead and complete my area model first. So I've got to be thinking, how many sections am I going to divide my rectangle into? Well, I have 1, 2, 3, 4 digits in my number. So I'm going to need 4 sections. 1, 2, 3, 4. Alright, now I've got to figure out, what am I going to label each of those sections? Well, remember, I've got to pull that number apart, and I've got to ask myself, what do each of those place values represent? So that 1 is not just a 1, it's a 1,000, because it's in the thousands place. That first 4 is not just a 4, it's a 400. My 2 is a 20, and my 4 is in fact a 4 because it's in the ones place. Now you should be asking yourself, okay, I've got those numbers, what do I do with them? Those are going to be what comes up at the top of your rectangle. So I've got 1,420 and 4. And if it helps you, you can put the little plus signs in there between them so that you remember that that's how you got those. One thing to remember, though, is that you need one number on top of each of your sections. So I shouldn't have 1,400 on this first section. It has to be 1,000 and then 400 on another section. Now finally, I'm thinking, okay, I'm solving for area. Area is length times width. Well, I've got my length. Those are my 4 numbers on top. What am I multiplying by? I'm multiplying by 4. And I got that from my original problem. Alright, next step, I need to solve for each of my boxes. So I'm thinking 1,000 times 4 is 4,000. 400 times 4, well, 4 times 4 is 16. And then I'm multiplying that by 100, so now I've got to bump it over 2 place values, so I've actually got 1,600. 4 times 20, 4 times 2 is 8, and I'm going to multiply by 10, so I need an extra 0. And 4 times 4 is 16. Alright, my final step for this, I've got to add all of those up, so I've now got 4,000 plus 1,600 plus 80 plus 16. Alright. 6, 9, 6, and 5. So 5,696 is what I've gotten for my area model. let's go over and let's try this with our partial products. So remember, before you do anything else on your partial products, label those place values. So you know that this is a 4, this is a 20, this is a 400, and this is a 1000. Not just the digits that are in there, but what place values do they represent? And if you look to see our comparison here, those are the exact same numbers that you split your 1424 into to get the numbers to place at the top of your area model. So again, these are very similar, they're just set up differently. Okay. 4 times 4 is 16. 4 times not just 2 but 20 is 80. 4 times 400 is 1,600. And 4 times 1,000 is 4,000. Add them up. We've got 6, 9, 6, and 5. So 5,696. 5,696. Excellent. We check out on this one. This next problem that we're going to complete, this is one that I want you to practice on your own and then come back and watch my work to see if what you got is what I got. But again, on this one, we're going to solve using the area model and partial products. We want to practice both of them, even though once you find a method that works for you, that's how I'm going to want you to continue to practice. But I do want you to be practicing different methods so that you know the choices that you have to work with and so that you can find the one that really best suits you when it comes to solving multiplication problems. So this is where I'd like you to pause. Go ahead, practice this problem. If you need to go back and re-watch a few steps on the last one, you can certainly do that to kind of help you boost yourself along. And then always come back and check this once you're done to see again if you are matching what I have. Alright, at this point you are checking in on your work. You've completed the area model, you've completed partial products for 3,034 times 3. Look over what you've got on your whiteboard or your piece of scratch paper. Check what I have and see, do you have the same answers? If not, go through and figure out where is your mistake. Is it you multiplied incorrectly? Is it we didn't line up our place values when we added? Where is the mistake that you have? If you don't have one, you've gotten 9,102 as your answer, then give yourself a pat on the back. Excellent job. One thing I'd like to point out to you that I did a little bit different on this problem than I did on the other two was that off to the side of my partial products, I just shared with you what problems it was that I solved in order to get that answer, just so you could get a good visual of where, again, I got those answers from. It's still these numbers that I have up top here, just written down below so that you can see exactly where I got that 12 from, where I got that 90 from, where I got that 0 from, and then finally where I got the 9,000. Another thing to note is that this one is a little bit different than the last one because we had a 0 in the mix. Now, when we wrote expanded form before, we said we didn't really need to keep track of that 0. It wasn't very important. But in the case of partial products and in the case of your area model, you do have to keep that 0, because if I were to just leave that 0 off, it's going to completely, I'm not going to have a label for the top of this column. Now, my answer ends up being 0, because we know that anything times 0 is 0, but it still needs to be there as a placeholder for us as we go to multiply, because if I just leave that 0 out, I could think that this 3 is a 300, or I could think that my 3,000 should be a 300. So we want to make sure that we keep that in there so that we don't mess up the outcome of our final answer. Alright, last problem that we're going to complete today is a word problem. It's going to pull from each of those skills, both partial products and area model, but have it in a real life, real world situation. So our problem that we have here is every day Penelope jogs 3 laps around the playground to keep in shape. The playground is rectangular with a width of 163 meters and a length of 320 meters. My first question, or my first problem, says find the total amount of meters in one lap. So that's what I'm going to focus on right now. I'm not going to even read question 2. I'm just going to focus on 1 right now. So my first thought here is, well, I should draw myself a rectangle, create an area model, because I think that will really help me in visualizing what it is Penelope is doing. So I'm going to draw a rectangle. Hopefully with a little bit straighter sides. There we go. Okay, so we know that she jogs around the rectangular playground. It has a width of 163 meters and has a length of 320 meters. Now, what side you put those numbers on, it doesn't really matter, but because the 320 is bigger, it makes most sense for that to be on the top, on the longer side. Okay, find the total amount of meters in one lap. So I've got to find, if she were to travel all the way around this playground, how far would she run in one lap? Well, if you're thinking what I'm thinking about my knowledge of perimeter. And I know that if this side is 320, that this side must also be 320. And if this side is 163, this side should also be 163. So now I've got all my side links, but I need to know the total amount of meters in one lap. So I'm thinking that I need to, in order to find the total, I'm going to need to add all of these numbers up. So I've got 320 plus 320 plus 163 plus 163. Now there's more than one way to solve this. You can certainly break it up into multiple problems. You could multiply by 2. You do what makes sense to you, as so long as you have all of those sides recorded in this problem that you're solving. So I've got 3 plus 3 is 6, 2 plus 2 is 4, plus 6 is 10, plus another 6 is 16, carry the 1, 1 plus 3 is 4, plus another 1 is 5, plus 3 is 8, plus 1 is 9. So I'm showing that my perimeter, P for perimeter, is 966 meters. That is the total amount for one lap traveled around the whole playground. So I've answered question 1. Question 2 says determine how many meters Penelope jogs in 3 laps. So if this is 1 lap, how many will she do in 3 laps? Well, I'm going to use my new multiplication skills that I've just learned, and I'm going to take her total of 1 lap, so 966, and I'm going to multiply by 3. Now you can set this up as an area model on your board. I'm going to only solve this using partial products today. However, I think we're going to have to bump it up here so that I can have a little bit more space to work. So 966 times 3. Okay, this is a 6, this is a 60 because it's in the tens place, and this is a 900 because the 9 is in the hundreds place. 3 times 6 is 18. 3 times not just 6, but 60. 3 times 6 is 36, times 10, bump it over, and I got a 0 on the end, so 360. And 3 times 900, well, 3 times 9 is 27, times 100 is 2,700. If you'll notice, knowing these math facts, knowing your multiplication and division facts come in handy when it comes to these problems, and will continue to come in handy as we continue forward with multiplication and on into division. So keep practicing those math facts. Alright, final step here, I've got to add. So 8 plus 0 is 8. 1 plus 6 plus 0 is 7. That's 10. Carry the 1. And that's 3. So I'm showing that for 1 lap it was 966 meters. But for 3 laps, Penelope would run 3,078 meters. And if I just think about, is this reasonable? I use my rounding skills. Well, 966 is almost about, I would say, hold on, let me change my color here, is about 1,000. I mean, that's pretty close. It's about 1,000. And if I take 1,000 times 3, that gives me 3,000, which is pretty close to what I have for my answer for 3 laps. So I would say that's pretty reasonable, and that's a good way for me to check my answer and say, you know, does this seem like it makes sense for the problem that I'm solving? All right, we're going to pause here for today. If you need to go back and rewatch any parts of this video, go ahead and do that. That's the beauty of having these videos. If you feel really comfortable with this, that's excellent. Keep pushing forward. We're going to be learning a new method tomorrow. So give yourself a pat on the back and good luck.